Assalamualaikum. Hello students. This is the Chemistry SK015 Pre-Lab module for Experiment 2 entitled Acid-Base Titration, Determination of the Concentration of Hydrochloric Acid. The learning outcomes are: at the end of this lesson, you should be able to: number 1, to define molarity and standard solution. Number 2, to state the use of standard solution. Number 3, to describe the preparation of a standard solution of oxalic acid. Number 4, to differentiate between endpoint and equivalence point. Number 5, to explain the precautions required during titration. And number 6, to calculate the concentration of hydrochloric solution in an acid-base titration. But first, please ensure that you have read the lab manual for Experiment 2 before proceeding with this video. First, try to understand the introduction for this experiment. It contained explanation about what is titration, standards in acid-base titration, equivalence point and end point, and the chemical equations involved. Then, please understand the procedure for each part of the experiment. In this experiment, there are 3 parts for you to practice. Part A, preparation of standard solution. Part B, standardization of 0.20 molar sodium hydroxide solution. And Part C, determination of the molar concentration of HCl solution. Here are the simplified procedures for you to follow during the experiment soon. So, are you ready for the activities? There are 3 activities for you. Activity 1, answer the question from the link given. Activity 2, briefly describe how to prepare 250 ml standard solution of hydrated oxalic acid with a concentration of 0.25 molar. This question is related to Part A in this experiment. In Part A, you have to weigh a certain amount of hydrated oxalic acid, and then you add distilled water to dissolve it, and then you transfer it into a 250 ml volumetric flask, and then you rinse the beaker and pour it into the volumetric flask, and then you add distilled water up to the calibrated mark, and then you stopper the volumetric flask and shake it. Meaning you have to find the mass of oxalic acid for this question. The mass can be calculated from mole. Mole is molarity times volume in unit liter. So you have to convert 250 ml to liter. The answer is 6.25 times 10 power negative 2 mole. So mass is mole times molar mass. Molar mass is 126 gram per mole. So the answer is 7.875 gram. Activity 3. Data analysis. A titration of 24.50 ml of an X molar HCl solution with 0.50 molar sodium hydroxide starts at a burette reading for sodium hydroxide of 0.50 ml. The burette reading of the endpoint is 5.40 ml. 1. What was the volume of sodium hydroxide dispensed? Given in the question, initial burette reading was 0.50 ml and the final burette reading was 5.40 ml. So, the volume of sodium hydroxide is final burette reading minus initial burette reading. So, the answer is 4.90 ml. Note that an accurate burette readings should be in 2 decimal places. 2. Calculate the number of moles of sodium hydroxide dispensed. Number of moles can be calculated from the formula of molarity. So mole equals to molarity times volume. Molarity given is 0.50 molar and the volume just now is 4.90. We convert it to liter. So the answer is 2.45 times 10 power of negative 3 mole. 3. Write the balance equation for the neutralization reaction. From neutralization reaction, you know that acid and base will produce salt and water. So, your acid is hydrochloric acid and your base is sodium hydroxide. So, it will produce sodium chloride and water. So, balance the equation. Make sure that the elements are balanced both side, right and left. So, this is the balance equation. 4. Calculate the number of moles of HCl present in the acid solution. From the balance equation, you know that 1 mole of sodium hydroxide will react with 1 mole of hydrochloric acid. So, if 2.45 times 10 to the power of negative 3 mole sodium hydroxide will react with the same amount, which is 2.45 times 10 to the power of negative 3 mole of hydrochloric acid. 5. Determine the value of X. So what is X? X is the molarity of hydrochloric acid. So molarity is equals to mole of solute divided by volume of solution in unit liter. So molarity of HCl is 2.45 times 10 to the power of negative 3 mole divided by 24.50 times 10 to the power of negative 3 to convert from ml to liter. So the answer is 0.10 molar. So, your task is to solve the data analysis question given in the pre-lab module. Well, all the best students. See you in the next video. Bye!